Hi, math students. Welcome to Project 2. Our first lesson for Project 2 is Lesson 6. And in this lesson, we've got 5 questions to go over, and it looks like we're solving some more crimes. So we're going to be looking at solving multi-step problems. And the first question is, first you need to find the first name of the culprit. The value of the variable x corresponds to the first name. The value of 5 times x minus 13 is 21 more than 3 times x. Okay, so let's scroll down so we can see our answers here too. All right. So what we need to do is we need to change this. Whoa, let's undo that. We need to change this into a mathematical statement instead of an English statement, okay? So we have 5 times x minus 13 is always corresponds to equals 21 more is plus than 3 times x, okay? So there's a couple different answers here. So we first had to find the proper equation. So it looks like choice A here is going to be our proper equation. But now we need to simplify and solve for x. So I am going to go ahead and subtract 3x from both sides. That'll be my first step here. Minus 3x and minus 3x, okay? When I do that, I get 2x minus 13 equals, equals 21. Okay, so, and that I can do that because 3x minus 3x is 0x, so it essentially cancels out over here. And now I'm going to add 13 to both sides to cancel it out on the left. So when I do that, I get 2x plus 0, so 2x equals 34. And now, last but not least, if I divide both sides by 2, it'll cancel this out, and I'll be left with x equals 17. So the second potential answer that I needed to select here is right here. X equals 17. I thought that the negative 17 was my only choice. Okay, so those two answers, it was 5x minus 13, it was A and B here. 5x minus 13 equals 3x plus 21, and x equals 17. So hopefully that makes sense. Let's go ahead and move on down to question 2. Okay, the table below shows the first name of each suspect paired with an equation. The culprit's equation will have the same solution as the equation in the previous question. So our solution was x equals 17. And so we need to figure out which one of these will also give us x equal 17. So let's just go ahead and work through each of these. If I solve 18 minus x over 2 equals 1, okay, first thing I'm going to do is multiply each side by 2, okay? And if I multiply this by 2 and I multiply this by 2, the 2's cancel out on the left, and I'm left with 18 minus x equals 2. And then if I subtract 18 from both sides, I get negative x equals a negative 16. So if I can then make both of these positive, essentially by multiplying each side by negative 1. And I get x equals 16. So that does not give us what we were looking for. All right. The first one is out. Okay, so let's try the second one. This was x equals 16. Second one, x plus 1 over 2 equals 1. So again, we're going to multiply both sides by 2, and we'll be left with them canceling out on the left, and on the right we'll get 2. So x plus 1 equals 2. If I subtract 1 from both sides, I get x equal 2 minus 1, which is 1. So again, we didn't come away with x equals 17. Instead, we came away with x equal 1. Okay, let's try one of these. They've got to be more promising here. Negative x over 2 plus 9 equals 1/2. Okay, well, the only thing that I can do here is subtract 9 from both sides. I can't multiply both sides by 2 quite yet because this 9 isn't being divided by 2. So I need to subtract 9 from both sides. So I'm going to have negative x over 2 equals, well, let's just do this. Let's say plus 9 minus 9 equals 1/2 minus 9. So these 9s will cancel out, and I'm left with negative x over 2 equals 8.5, right? A negative 8.5, negative 8.5. Okay, now I can multiply both sides by 2. So let's go ahead and do that. And when I do that, they cancel out on the left, and I have negative x equals negative 17. Okay, so this negative is essentially a negative 1 times x. So to get rid of that negative, I can divide both sides by negative 1. And when I do that, they cancel out on the left, and I have an x equals positive 17 remaining. Cool. So it would appear that the first name of my culprit is Terry. Okay. We could continue to go through this, but I would challenge you, if you don't believe that it's not Noel or Noel, I'm not sure how you pronounce that. If you don't believe it, just go ahead and check and solve for x there, and you will probably find that it equals a negative 16 there. So that isn't it. All right, so question 3. Some mysterious value g is given by the formula g equals 3a over 2y. However, to find the middle name of the culprit, we need to derive the formula for y in terms of g. So that's how we're going to find the middle name. The detective knows that he needs to isolate the variable y to find the formula. So these are the steps that he takes. First, he subtracts 3a on both sides, and he gets g minus 3a equals 2y. Then he divides by 2 on both sides, and he gets g minus 3a over 2. So we have to decide if he's right. So let's us go ahead and do this. My pen doesn't want to work. G equals 3a over 2y. Okay, so we cannot subtract 3a first because it's being divided by 2y. So we could subtract 3a over 2y, but that doesn't really get us anywhere. The thing that we need to do is to get that y up into the numerator. So we're going to multiply both sides by 2y. Okay. And when we do that, it cancels out on the left, and we have 2y g equals 3a. All right. Now, if I need to get y all by itself, I'm multiplying by 2 and g, so I can simply divide by 2 and g, and these will cancel out. And I have y equal 3a over 2g. So I know that the suspect's name is Terry Elliott. Okay, and the answer that we should choose here is he should first multiply both sides of the equation by 2y. So, and then divide both sides by 2g. Okay. Question 4, another mystery value m is given by the formula m equals the quantity zn squared. We want to solve the equation for z when m equals 36, n equals 3, and z is a positive number. Okay, so we want to rearrange this equation to solve for z. So when the opposite of squaring something is taking the square root. So if I take the square root of the right-hand side, I have to also take the square root of the left-hand side. So zn squared, and if I take the square root of that, okay, then I will end up with the square root of m equals zn. Okay, now to solve for z, all I need to do is divide both sides by n. Okay, and I just want to clarify here really quick. Taking the square root of something is the same as taking it to the 1/2 power. So this would be doing this. It would be zn squared, and then all of that to the 1/2. Okay, and when you take a power to a power, you multiply. So 2 times 1/2 is 1. So this just becomes zn to the first power, which is zn. So to undo a root, you or to undo something like squared, you would take the square root. If this were cubed, you would take the cubic root, and that's how you undo those. So now those n's are going to cancel out, and if m is 36, I'm going to plug this in, the square root of 36 over 3. The square root of 36 is 6 over 3 equals 2. Okay, square root of 36 could also be a -6, but it told us to look for the positive. So I believe we ended up with Terry Elliott Dobson. Okay. And I will let you fill in the last one, Terry Elliott Dobson, and just describe what we did in each of those problems. You don't need to go into great detail there, but the answer there is Terry Elliott Dobson, and you rearranged mathematical formulas to arrive at the right answers there. So thank you for taking the time to listen to the Unit 2 Lesson 6 project, and I hope you do well on this assignment.